So I'm Eugene, and I'm glad to tell you some facts about Kotlin. I'm not sure if you have ever tried Kotlin before, but please don't think I will not explain you the basics of Kotlin. I would rather try to spark some interest or some fun around the Kotlin and some random facts around it. I especially picked the facts which are not obvious. I hope so. Well, if I'm not telling you the truth, tell me in the comments or in the questions. I'll be happy to know if it's obvious fact or not. Okay, so to start with, you may notice that there is something strange in this title of this presentation, and in fact, it's not a smiley, and in fact, it's a feature which is added to the recently released Kotlin 1.4. So now you can use the commas at the end of the last parameter in a function calls, for example. And it's cool if you, for example, ever tried the Go programming language, you may have experienced it this way, but here in Kotlin, you are not forced to use it. It's optional, but you can use it. Why? Well, if someone else would come to include yet another line, there would be only one line change, not two lines change. Well, it's good, at least for me, because I will generate 2 times less line changes within a day of work. For others, it might be a trouble because you no longer need to update the upper line and you don't longer need to change and to struggle with the Git merges when I added a colon, comma, and someone added yet another comma and so on. Well, this is a feature on 1.4 and it's actually the warm-up. The thing is that I decided to go a little bit history, and I would like to explain why Kotlin. Kotlin was started almost 9 years ago, and at JetBrains, 9 years ago, it's 2011 or something, we had a huge Java application, which is called IntelliJ, and we've been supporting several programming languages in this IDE. And at that time, we decided to give it a try to figure out what is the best language for us at JetBrains to develop IntelliJ further. And by that time, 9 years ago, Java was not evolving that fast as it does now, and then there are several other programming languages flourishing around JVM platform, so we've made it a try. And even more, actually, some of these experiments are still in the open source repo of IntelliJ community, for example, so we did it a try, and unfortunately, we figured out no silver bullet around, and we decided to experiment on having yet another language to solve our problems, and which we would like to use. And the first one is concise. Sometimes you generate a code, say in Java or in any other languages with your IDE or manually, and it's better to make the language designed the way where you don't need it, so you can just express what you need in a shorter ways. Or for example, if you generated some equals or hash codes, say in Java, you never know if it's generated or someone patched it, especially for some specific behavior. It's all the time a really good investigation if you see something going wrong around this. The safetiness, or null safeness, it's a so-called $1 billion problem. I mean that in a language, in Kotlin, the null pointer checks are embedded into the language, so you are unlikely to have these null pointer problems when you program with Kotlin, which helps to generate the safe code. Interoperable, and for us, 9 years ago, we had a huge almost 10 years old Java application, and saying, okay, we're going to rewrite it into a new language was not a viable solution. Instead, we invested into the interoperability. So you can use Kotlin along with existing Java or Android or iOS or even Objective-C code, and you can reuse it together with Kotlin so it would go easier. And the last thing is tool-friendliness. I mean that if you're going to use the new language, say you would try to use Kotlin, or say you would going to try yet any language. With the tooling, it helps. So you may even have no understanding how it works. You just copy Java code and paste it into a Kotlin file, and it's converted to Kotlin. So you may learn by example on how to deal with it. So it should help. And there at the beginning, the language was called Jet, and its internal code name, and actually, at JetBrains, we had several kind of a history of naming something with the Jet prefix, like Jet Food, Jet Post, or Jet Service, Jet Launcher, and other stuff. And later, actually, I do have a proof. So in the project files of IntelliJ, we used to have this Jet language longer than the language was actually called Jet. Well, and later, closer to their public announcement in 2011, the language was named Kotlin. It was a temporary, internal code name for any official stuff. And we got this fancy logos at that time, and they're, oh, sorry. Well, it's also Kotlin, but it's not the real one. It's in Poland, and it's called Kotlin as well. Okay, and now I'm gonna go further. So Kotlin got this the website in 2014, but actually this Kotlin thing is, I don't know, it's way older than Kotlin. And if you're saying in Poland, just take a selfie. It's cool, isn't it? So you may Google it. It's easy to find, or in my slides there is a link to this place. Okay, and then it's the first website of Kotlin. There is, I don't know whose booths out here. Anyways, and there several years later we got the Kotlin 1.0, and this is the actual website of Kotlin. It's nothing special, but the version is 1.4 now. And before this, we used to have this website. I really like this one because this lighthouse, it's not the stock photo. This photo has a history which is really related to Kotlin. So I just found yet another photo of this lighthouse. And guess what? This lighthouse is an island, which is called Kotlin. So this island is not that far from St. Petersburg, and essentially not that far from St. Petersburg office of JetBrains. It's almost 32 kilometers. And I used to joke that from their meeting room on that office, it's almost visible. So you may almost see this island from the window. Well, and there, again, I have some proof on this. This is a really cool book. It's a Kotlin in Action book by Dmitry Jemerov and Svetlana Isakova, explaining the basics of Kotlin. And they have this the explanation about the name and the namesake island. Even more, it is Dmitry Jemerov who took this original photo from the website. This is a fun fact, I hope. Okay. I think you were expecting like some programming or stuff, not the history, and I'm not the lecturer for history, so I came up with a warm-up for you. And so how would you feel? What's the answer? Even if you see the Kotlin for the first time, just think the val is the same as var in Java 11, and this is a definition of a variable, and you print the answer. And if you have uncertainty or you're not sure what's going on, you may open this on a play.kotlinlang.org on your mobile browser or even in your browser and take a look and give it a try to see samples or try yet another one. And in fact, here I made a mistake. You see, this is the real word wrap essentially. So I would ask you to say, what is now plus now in Kotlin? Will it compile? Will it print something? How it would work? And now I'm going to explain it to you. So actually the plus in Kotlin is the operator. And in Kotlin you can do the overload operators. Only the standard operators you can overload. And essentially this is the definition of this plus operator. It takes the string with question mark, meaning that the string can have null value, and it takes another nullable value, and it prints the combined string. And here is the trick, and it's written in this Java doc, that if the value of the parameter is null, then it would yield the null quoted, right? So essentially the example I showed you before is equivalent to this one. So instead of calling this the plus operator, you must simply call the function plus. And the fact that we call it on the null is not the problem, because this plus is an extension function, it's not a member function. So essentially it's just a static utility function which takes two parameters. And now we are really close to the answer. And actually the answer is this. Well, I'm sorry for it, but this is not the puzzler's talk. I'm not talking puzzlers here, so we're gonna fix it. So how we can fix it? If you see something going wrong in your program, you can either do the runtime check or the compile time check. Let's start with the first one. For this one, we need a specific type nothing, which comes from the Kotlin library, and this type helps to have the runtime check. And even compiler understands that as long as I return the nothing from my plus function, the computation would not go any further. So this is why this unreachable code highlighting comes into, say, IntelliJ or in the compiler warnings. But okay, it's good, right? So now our program is unlikely to work, so half done. But actually, I don't like this approach, because you never know if this happening in your code base or not. You need to have tests, you need to have a crazy coverage for unit tests or integration tests. It's better if the program would not even compile, and it is actually possible to do. And the deprecated fun is the way how we achieve it. The deprecated annotation in Kotlin is really powerful. It has the level parameter where you can specify how you would like this deprecation to be treated by the compiler. And the trick is that you may say, okay, fine, I'd like the level error, it would mean that the compiler would reject compiling the usage of this function. But the function would be still in the bytecode for your backward compatibility, so all their code would go. But the newer code would not compile. For some case, you may even say the level equals to hidden to hide some declaration from your program, but keep it at the bytecode level. So now compiler would reject compiling this program, and I'm happy I solved it, so no one would be able to compile it. Fine, great. So everyone who managed to have this example had to fix it. Fine, done. And it is done thanks to nothing. Well, nothing is a type in Kotlin standard library, and I told you nothing about nothing, but let me fix it. The nothing is a specific type in Kotlin which has no values. Actually, it's an imaginary type. There is no real type nothing in the standard library, so it's only in the compiler. And as long as this type has no values, the compiler assumes that this is a subtype of any type in the ecosystem, like a subtype of string or object or int or small int, any. And in fact, for their execution, this only possibility is to stop the execution, like by throwing an exception or killing the process. And this is how you can return the nothing from your function. And here's a powerful example. Say in your program, you need a specific assertion or specific crash function or like exit process function. And you can declare it with type nothing in Kotlin. And this is how you do it in the top of the slide is shown. And then the place where you use it, you no longer need to make a compiler happier because the compiler knows that the execution would not go any further. Cool, isn't it? And we may have many more examples of the type nothing, like return, like throw. These expressions have the type nothing. And it helps when you combine this together with different other functions in your code. Let me show you an example. So the to-do. The to-do function just throws an exception that something is not implemented, and I can use it this way. In Kotlin, you may declare a function which just returns an expression. It's with the equal sign without the brackets and the return statement. It's a shorter way to declare functions. And in this particular example, I'm going to write some algorithm, and I do need these functions for my algorithm to experiment. And I don't want to implement these functions right now, so I can use the to-do function to implement this. It's the shorter way from the standard, the way how we do it in, say, in Java or in C, like throwing an exception in C++. There is no exceptions in C, sadly. Well, so I've declared this way. As long as the to-do returns nothing, the compiler is totally happy to say, okay, nothing is a subtype of an nullable string or a nullable item. That's all fine, right? Now I came up with my fancy algorithm. It's like it finds an item, then it loads some info. Well, and when you code in Kotlin and you use an IDE or a compiler output, in IDE you may see this gray highlighting. You see it on the slide, right? And if you see it, and if you feel like you would like to spend some time to have more idiomatic code, what do? You just click on this light bulb in the editor and just apply what it suggests to you. So for now, it applies to use an Elvis operator, and you can see it on the button with a question and a colon operator. It's easy. It takes the left side. If the left side is null, then it evaluates the right side. And the type of the whole expression is inferred for you by the compiler. So it's equivalent code, but it's way shorter. And thanks to nothing type, the throw exception has type nothing. So the compiler knows that info now is not nullable info. Great, isn't it? And I would continue applying this light bulb in the expression above. And finally, I came up with an idiomatic and a shorter way to write the same program. So I've replaced all the explicit null checks with an operator. And it looks like this now. And I would recall you that it used to look like like 10 lines. And now it's almost 2 lines. And if I no longer care about the exception, say I find to return a null, I can come up with this solution. This is called the save call, the question and a dot operator. So what it does, it takes the left side. If the left side is not null, it calls the method load info. Otherwise, the total result is null. That's it. That's so short and so fun. Even more, I can use their functional programming if I like. So that's up to me to decide whether it's okay or not. And essentially, I have a giveaway here for you, or even a joke. If someone would ask you how to make my code more idiomatic, you may say nothing helps to clean this code. I mean, nothing type helps. Then if you would do this joke, please explain something about nothing. Because if you would not explain nothing, it would not work the right way. Okay. Now we're gonna go a little bit harder and we speak about generics. Have you ever tried writing generics in Java for JVM, say? Actually, you might use the Kotlin and do generics in JavaScript, but we won't cover this. Well, say I have a function which takes the type parameter and returns nullable or runnable. It takes type parameter which must implement number and runnable. And the question is, how would it look in the bytecode level at the JVM? What I do the following trick. Of course, you can compile this class and you use some J tool to decompile it, but I show the UI way. You use the show Kotlin bytecode action in IDE, and then you can read the Kotlin JVM bytecode of this class and this Kotlin file. It's hard, and not sure everyone can read it. I don't like it. I'm not sure I even understand what's written in this bytecode, but I click the decompile button, and that's in the magic. So we take a Kotlin file, we generate the bytecode, the JVM bytecode, and then we use the Java decompiler to see what's going on inside. This is the way to figure out what's going on in Kotlin if you are not sure what's going on in there. Sometimes Java decompiler takes hard time understanding it, but sometimes it works. And in our case, it works. And you see the fact that the type parameter has disappeared. It's no longer there. This is how JVM works. And Brian Gertz had a really cool talk, the blog post about this. You can find it in this presentation notes. So anyways, there is no type parameter, and the types are substituted with their upper bound. So, well, what's going on? It's not what I expected it to, but here's an example for you. Like, sometimes we do cast to T in our Java or in Kotlin, and most IDEs say, it's probably not a good idea to cast to T. Are you sure? It's a warning, it's not a compilation error. And I came up with yet another solution. The only difference is that it's called the redefined inline function, and the compiler is happy about it. Let me run an experiment. So I call the first one, and you may do this experiment in Java if you like. And the second one, so I call the first function and the second function from the wrong type. So it's supposed to crash, right? Do you think it would crash? Well, let me show. I do the decompile once again, and what we have in the first one, we see, oh, what's going on? It will not crash because the types are erased, so it was object, it's cast to object, no one need to cast to object, so there is no cast any longer. Fine. Oh, wow. So the string would go as in, and it's all good. And whereas from the refined function, this inline function in Kotlin, this specific feature of Kotlin, so the function body is inlined in the place where you call it, and the type cast is inlined as well, so we do have the real cast in this example, and it will crash. This is what we expected it to be. So as for type erasure, the type erasure is the way how generics are implemented for the JVM platform. So it's no matter if you use Java, Kotlin, Scala, whatever, there is no type generics at the moment where the bytecode is executed. There are some types in their meta information, but not at the place where execution comes. So at the compiler, what it does, it takes all the type parameters, it replaces it with the upper bounds, like object or any constraint which you have. Compiler inserts all the necessary cast all over the place. And compiler even creates methods, like a bridge methods, where you have a method from T, and you specify it with a specific T, so the compiler will create a method to make sure that at the execution it looks like it's right parameterized. That's it. And what we can do to work around the problems I've shown you, the first, it's probably not a good idea to cast to T. Even if you, for example, you may have the generics from generics like kind of really generified code, and then it might be really hard to find where you missed the right cast. The workaround is quite easy. You may use the class from the big C in Java and use its cast method. It's the way to make sure that the T is right T at that given place. And as for refined generics, if you use Kotlin, you may use the inline function, which I've shown you. Is such a function which inlined into place where you call it. It works really cool with lambdas. So if you have a inline function which takes a lambda, in Kotlin, it would be just a code. Like, for example, you do filtering on the collections. It will be inline, so you will not create an object for this lambda, you will not allocate it, it will be just inlined in the place where you call it. And the refined type parameters are the type parameters which are also inlined at that place. That's the refined generics. And it really helps, like, for example, to implement this trick, the reading JSON. I create a function which refined generic, which called load, which takes a JSON text, for example, and it's supposed to return the type T for me. And it works okay for, say, for monstrous list, map, string, int, or it works for any types, because where I call this function, it is inlined, and I know for sure which type with which generics I have, so I can call my library, pass there the right type, and it would work. Really short and really clear in this example. Well, it was nice, and yet another cool feature in Kotlin is the coroutines for non-blocking programming. I mean that where you can use where you can have a suspend functions, the functions which can suspend in the middle and be resumed later. It opens the way to deal with channels, the flows, the select operators, the futures, and so on. This is the Kotlin X coroutines library to help you deal with their concurrent programming. And there are so many features, so it doesn't fit here on the screen. I would show a really interesting example where coroutines can help. So I have a recursion function. If we have a recursion function, what happens? Well, usually it may crash with a stack overflow. It happens. And the workaround could be beyond the obvious, could be to use the tailrec in Kotlin. There's a specific keyword in Kotlin which helps to turn the recursive function into a loop, but only for a tail recursive function. And it's not my case. Yet another approach, which we all know, is to use them to just manually replace the recursive calls with actually the heap and the loop. So you create some queue and you pass the parameters into the queue, and then you have a loop to process these parameters and put yet another parameters into the queue or something like that. Well, it's all possible, but I have a shorter and simpler solution for you. It's called the deep recursive function, deep recursive coroutine, or deep recursive function. This is the thing it's added into Kotlin 1.4. And what it does, it uses the suspend functions to implement this this stack unwrap for you. So actually, I use exactly the same function as I had before, but I call this the co-recursive helper function instead of just a recursive call. And this is enough. So the Kotlin compiler implement this as a suspend function. And the place where I call this recursive, the function suspends, so its state is persisted on the heap. Then we call the next instance of this function. And so we have such a queue, and we process this queue, and finally we have results. So no stack overflow is thrown here. This is what you can achieve using coroutines. And it's the smallest particle which you can achieve using coroutines, because they're non-blocking, and concurrent programming is the way where it flourishes the best. Well, Kotlin is really nice to build with, and you can build different things with Kotlin. For example, I decided to create a Conway game of life algorithm. So this is the 2D mesh, and there are the ways how you define the color of the pixels, and then you can do such an animation. And it was cool and nice for me to give it a try. And I decided to implement this somehow in Kotlin, so I wrote this code. It works for me. And then I realized that I can use the Unicode symbols to present this instead of the white and the black colors. I use these the Unicode emojis to implement this. This is a well-known glider pattern. And then I realized that I can use the same code. I can keep experiment, and I can run this code on my Raspberry Pi or somewhere without any JVM. This is a Kotlin native, which helps me. So I can compile the same program for different platform. And then I use some DSL. The language of Kotlin allows you to do DSLs. And this DSL helped me to show the same algorithm as HTML JavaScript page. So I compile my Kotlin code into JavaScript. Then I use the same thing for iOS, and I finally compile and mix it with Swift, and I came up with the same algorithm running on iPhone. That's the same language, so I can keep reusing the languages, the platforms, and I have the same code for it. And this is how I managed to make this one. I use the server side, and I render this image with the JVM AWT. And this is called the Kotlin Multi-Platform Mobile, KMM, or you may have the older names like MPP. It supports Android, iOS, and there are many platforms and targets, and you can reuse your code really, really, really. Oh, okay. So that's another Kotlin. That's a slide from the beginning. And if someone would ask you, how can you use Kotlin? This is yet another example where you can use Kotlin. Well, and on the server side, you can use Cater.io, this asynchronous framework. You can use Kotlin to do serverless programming. And this is all you can use, and you can use the ecosystem, like JVM ecosystem, iOS, Android, or JS, to manage the benefit from it. You don't need to write anything. It's interops with almost this. JetBrains, we use Kotlin in almost every project, even the server side, their desktop or web. It's really cool. And also this ISM ACPC supports Kotlin for many years. So if you compete with the programming, you can use Kotlin in there as well. And if you do Kotlin, well, you might probably expect fun. And the thing is that if you ever wrote expect fun in Kotlin, you're likely to have actual fun at the end, because this is the keywords we use for the Kotlin multi-platform programming. So I hope you would expect fun, or you had some interesting ideas today. So I'm really open to have some questions at the end. So thank you for your time.